The main object of this program is to calculate factorial value of a given integer. Essentially, here this program is written based on the previous example, in which we have written a while loop which will start from 1 and goes on executes till I variable value becomes n. We know that factorial value of an integer n is equal to 1 into 2 into 3 into etc. n. Thus we will be selecting the variable I value as 1, and it will be allowed to increment 1 by 1 till it reaches the n value, and each time we try to use this I variable value and multiply with a variable whose initial value is 1. Thus we will get 1 into 2 into 3 into etc. We have declared the variables I and n. This scanf statement reads an integer number whatever user enters and stores in this variable n. As already mentioned, the variable value 1 is required to change from 1 to till n. Thus this while loop is written such that I value will change at the steps of 1 till it approaches n. And now I value is used in calculating the factorial value. F is equal to f into I statement is used such a way that f value initially 1, and then 1 into 1 becomes 1, again 1 into 2 it becomes 2, and 2 into 3 it becomes 6, and vice versa. The last printf statement is used to print the factorial value f. Now let us try to simulate this while loop. We assume that the user has entered n value as 5, and now our simulation goes on. Initial value of I is 1. We forgot to make f value is 1. Thus we have corrected. We have made an instruction f is equal to 1 in the program, and the same is being entered into the variable, into the table under the variable f. Now I value is compared against n in the while loop. Initially I value is 1, n is 5. Does 1 is less than n? Yes. Thus the while loop is true. We'll go into the loop and then the statements will be executed. Now f is equal to f into I, that is 1 into 1 is calculated and stored under f. I value is incremented by 1, thus I value becomes 2. Again I value is now compared with n. I value is 2, n is 5, thus 2 is less than or equal to 5, thus the loop is true. So again the loop will be executed once more. Now f is equal to f into I is calculated, f value becomes 2. I value is again incremented by 1, thus I value becomes 3. Now loop condition is again tested. I value is 3, 3 is less than or equal to 5, thus again loop will be executed once more. F is equal to f into I is again executed, thus f value becomes 6. I is again incremented by 1, thus I value becomes 4. Now I is again compared with n, so the condition is true, thus the loop will be executed once more. F is equal to f into I calculated, thus f value becomes 24. I value is again incremented, thus I value becomes 5. Again while condition is tested, I 5, n is 5, 5 less than or equal to 5, yes. Thus again loop is going to be executed once more. (24) into 5, that is 120 is calculated and is stored in this variable f. I value is again incremented by 1, so I value becomes 6 now. Again while condition is tested, currently the variable I value is 6. 6 is it less than or equal to n? Yeah, no, that is the reason why the loop will not be executed any longer. The program execution comes out from the while loop. By this time, f contains 1 into 2 into 3 into 4 into 5, that is 120, which is nothing but factorial 5 value. So the last printf statement will simply print f120. However, we have to understand one important aspect here. As n value is 5, it's very easy, we may get the factorial value, because we have declared f is a integer type of variable, and there are some missions which uses 2 bytes only for the integer variable. Thus the largest number what we can store in a 2 byte integer is 32767. When we carry out this multiplication operation 1 into 2, 2 into 3, etc., if it is more than 32767, the f value finally contains trash value. Thus, this program will have limitations on a 2 byte machine. You can check up by giving n value as 9 or maybe little more than that. Obviously, if you want to get rid of this problem, you may have to work on a machine whose word size is maybe more than 2 bytes. Let it be 4 byte. There also again you may face a problem that it may work for n value of 17 or so. After that it may also not give. So these are the practical difficulties of the programs.